This is for STA2023 Statistical Methods, Chapter 8, Video 2. On the previous example, all of the calculator steps are here in the notes, step by step by step. So if you have any questions, you can go step by step. Each calculator is a little different, but this one's for the TI-8384. That was for the test. This is for the confidence interval. Okay, we're going to do two more examples in this video. It's going to be the same thing over and over again, so I'll go a little quickly, but again, you got to make sure you understand the concept. So it is reported that 29% of people dream in color. A researcher took a random sample of 113 people and 92 reported that they dream in color. Is there enough evidence at the 5% level that 29% or more of people dream in color? So if we break this down, 29% of all people dream in color, that's our P. P hat is our sample, 92 out of 113, 0.81%. Sample size 113, alpha is 0.05, and we're looking for more than. Now again, I always like to stop and what are we talking about? The claim is 29%, and you think it's greater than 29%, and your evidence is 81%. So do you feel that 81 is very far away from 29, so you have enough evidence to say that 29 is wrong? Okay, so HO, P is equal to 0.29. The proportion of people who dream in color is 29. And you're arguing that P is greater than 0.29. The proportion of people who dream in color is greater than 29%. Remember, HO is always equals. HA is the same number. Kind of think of it being on trial. It's the same person on trial. That's the claim. You just think it's greater than 29%. We're going to check our conditions. Was it random? Stated. The population, all people, is greater than 10 times 113, which is 1,130. And N times P, 113 times 0.29 is 32.77, which is greater than 10. N times 1 minus P, 113 times 1 minus 0.29 is 80.23. That's greater than or equal to 10. So we find our SE. Be very careful. It's the square root of P, 0.29, times 1 minus P, 1 minus 0.29, over N, which is 113. So our SE is 0.043. To find your Z-score, it's P hat, 0.81, minus 0.29 over 0.043, which gives us a Z-score of 12, which is really big. Really big. So our Z-score of 12 is off the chart. So if you're using the table, it's off the chart. So usually what I recommend to people when it's off the chart is just call the p-value 0.9999. Here I use 9998, which is fine too. It's really small. The exact p-value is probably 9999999. You get the idea. So if you get anything off the chart, you can use 0.9999 or extra 9s or even the 8. It's okay. But the idea is that that's less than. If we're looking for more than, for the 100 minus 99.99 or 98, you get 0.02 or 0.01%. But the p-value is very small, 0.0002 or 0.0001. But the idea is the p-value is very small. And when you compare that p-value to your alpha, it's definitely smaller. But we'll check in the calculator real quick. So if we go to our calculator, turn it on, we do stat, test. Remember doing number 5, 1 proportion Z test. The claim is 0.29. Remember the calculator wants the fraction. 92 out of 113. We're looking for greater than again. You can choose draw. And since it's so small, your calculator will probably report P to be 0. So p-value is 12.28. There's your Z. And your p-value is essentially 0. It's not exactly 0, but it's essentially 0. If you'd like to find exactly what it is, when you go to test, number 5, choose calculate, your exact p-value is right here, 6.04, but it's e to the negative 35. That means you have to move that decimal 35 places to the left. It's 0.3406. 0.3406. It's very small. Okay, so anyways, our p-value is definitely smaller than alpha. You can use the chart. When your p-value is smaller than alpha, we reject HO. Why? There is statistically significant evidence to reject HO because that really small p-value, which is actually 0.3406, and we conclude the proportion of people who dream in color is greater than 29%. So in this example, we were hoping it was greater than 29, and we do have enough evidence to say it's greater than 29. We can reject the claim, the HO. Then to verify that, we're going to do our confidence interval. It's p hat, 0.81, plus or minus z star, because we're doing 95%, you can use 2 or 1.96 times our SE, and we get 72.4% and 89.6%, which again we can check in the calculator. If we go to stat, test, number 5 is the test, but we're doing an interval, so we're going to go all the way down to A. So for the interval, we want the fraction. Again, it's 95%. We hit calculate. Notice by hand we got 72, and the calculator we got 74. Still very close. If you want to be exact, go with the calculator. This is more of a rounding. But we are 95% confident the proportion of people who dream in color is between 72.4% and 89.4%. Now remember, the claim is 29. 29 is not on the interval. This interval, the entire interval, is greater than 29, so it verifies our conclusion of being greater than 29. Okay? Next example. It is reported that 31% of U.S. drivers age 18 to 64 say they read or sent text messages or email messages while driving. A researcher took a random sample of 500 U.S. drivers age 18 to 64, and 200 reported that they read or sent text messages or email messages while driving. Is there enough evidence at the 10% level U.S. drivers ages 18 to 64 that have read or sent text messages or email messages while driving is not equal to 31%? So again, P is 31%, P hat is 200 out of 500, which is 0.40, N is 500, alpha is 0.10. So, claim is 31, our evidence is 40. Is that far enough away to say our claim is wrong? We'll see. Run the numbers. And this time alpha is 0.10, 10%, which means it's a little bit easier to reject than 5%. But still, be careful of what's given. So, HO, P equals 0.31. The proportion of U.S. drivers 18 to 64 who text while driving is 31%. HA, not equal to, again, given in the problem, the proportion of U.S. drivers 18 to 64 who text while driving is not equal to 31%. We'll check our conditions. It's random, stated. All U.S. drivers 18 to 64 is greater than 10 times 500, which is 5,000. 500 times 0.31 is 155, that is greater than 10. And 500 times 1 minus 0.31, 345 is greater than 10. Pass all the conditions. We find our SE, square root of 0.31, 1 minus 0.31 over 500, which gives us 0.021. Z is 0.40, P hat minus P, 0.31, over your SE, 0.021, which gives us a Z of 429. Again, that's off the chart. Anything that's off the chart, we can call 0.999. The calculator will give us the exact answer. So if I put it, that should be way down here. 4.29, if we use 0.999, if we subtract from 100, you get 0.001. Now, when it's not equal to, we multiply by 2. Now, why is that? Less than checks if it's lower. More than checks if it's more than. Not equal to checks both. Both. Less than and more than, both ends, both tails. So that's why I multiply by 2. So I took my 0.0001 times 2 and got 0.0002. Still very, very, very small. Very small. We'll check that in the calculator. So we go to stat, test, number 5. Remember the claim is 0.31. Our fraction is 200 out of 500. This time not equal to. If we go to draw, now you notice we're not going to see any shading. It would be shaded on the left and on the right, but because it's so small, essentially zero, you don't see the shading on both sides. The p-value is very close. You could also do test number 5 and choose calculate. And it gives you just the p-value. The exact p-value would be, move it over 5 spaces, 0.00001. It's very small, very small. So our p-value is smaller than alpha, so we reject HO. There is statistically significant evidence to reject HO because our p-value is so small. We conclude the proportion of U.S. drivers 18 to 64 who text message while driving is not equal to 31%. Not equal. So remember, if we go back to our conclusion chart, I'm going to scroll up here. At our conclusion chart, if you reject, we put not equal to. If we fail to reject, I would have written not different than. So it depends on what side you're on. So use that conclusion chart to help you. But the idea is that it's supposed to be 31%. We're saying that it's not equal to 31%. We reject the claim of 31%. There is enough evidence to reject that claim. We conclude the proportion of U.S. drivers 18 to 64 who text message while driving is not equal to 31. Now to verify that, we do p hat, 0.40, plus or minus z star. Since we're doing a 90% confidence interval, alpha is 10, 90% confident. Z star is 1.645 times our SE of 0.021. We get 0.365 and 0.435. And we can check that in the calculator. Remember, we go to stat, test, all the way down to A, all the way down to A. 200 out of 500. Make sure you change your confidence interval to 90. Be careful with that. And we calculate to get you 0.36. We got 0.36, 0.43, 0.43, very close. So we can say we are 90% confident the proportion of U.S. drivers 18 to 64 who text while driving is between 36.5% and 43.5%. Remember, the claim was 31%. That's the claim. Our interval is between 36 and 43. 31 is not in the interval, so it's not equal to 31%. Everything verifies itself.